Okay, I am now recording. We are talking about limit notation. F of x approaching infinity, or x approaching infinity and negative infinity. And we just talked about 5a and just recapped how this limit notation works. Our old notation talks about what x does. And as x does this, y does this. And we are talking about how to rewrite that in limit notation, just kind of reformat the way we are expressing this idea. So we're on 5b, and Cassie's going to tell me what this equation equals. Was it f of x or g of x or something?
G of x.
All right, so sorry I forgot to hit the record button. Okay, so this one is rational, which is with our unit. So this one has some lead terms to look at right here. Okay, pipe up, anybody. Would you call that bottom, top heavy, or balanced?
Bottom heavy.
Did I hear balanced or did I hear heavy something?
Balanced.
So y equals 2x over 3x gives us a simplified y equals 2/3. And the ends of a y equals 2/3 constant graph are leveled off like this. So we are just going to write down that idea, and we're going to use that limit notation. Okay, do you guys want to see this, or do you want me to call on one of you to
Can we see it?
Yeah, okay. So the right end, always the right end starts the same way. Limit as x goes to infinity of g of x in this case. So we always name our function right there. Okay, you always start the right end of the right end behavior is always going to be written this way. And then what it equals. So what does y do as we head here? Look at your y value. Where's y headed? And that's that 2/3 number for this horizontal asymptote. Okay, so this is how you'd write the right end behavior. Any idea how you would do the left end? How's the left end going to be different?
It has x approach negative infinity.
Exactly right. So that's really the only difference. X is going to negative infinity, and the y is still going the same place it was on the right end. It's still going to the 2/3 level right there. So we just put the 2/3 in there. Okay, so this is a statement about what x is doing, and out here we're saying it equals this value that y is getting closer to. Okay, so there is a related question to this on your review that was also brought up in the questions I got earlier. It is number 4. You guys have your review. I do have my review now. I've got it from Canvas here. This one is a word problem. Can I get somebody to read it? Who had that question? I don't remember.
I can read it.
Go ahead.
Yes. A factory dumped a large quantity of pollutants into a stream at t equals 0. The amount in grams per gallon of pollutants in the lake fed by the stream is given by f of t equals 2t squared plus t plus 82 over t squared minus t plus 3. Describe what will happen to the level of pollutants in the lake as time goes by.
Okay, so I heard you say what this meant, something about the amount of pollutants or something like that. Is that right?
Like t equals 0? Oh, the amount in grams per gallon of pollutants in the lake fed by the stream.
Amount of pollutants, I'm spelling it wrong and I don't care. In the stream?
Yeah.
And t is the variable that represents time, right?
I think so.
Remember if it was measured in years or in days or what? The question again, I lost my review. What happens when what?
To the level of pollutants in the lake as time goes by.
What happens to the pollution as time goes? So this question right here, when it says as time goes by, right there, mathematically that means t, since t is time, goes on and on and on and on and on and on. And there's our notation for it. Does that look familiar? I can't read your faces. I need answers.
Yeah.
Yeah,
Where
that
have
makes
you
sense.
seen
Yeah.
this before?
Is it like when x approaches infinity?
Yeah. Yeah, it's exactly the same thing. So when we say x is going to infinity, we're letting it go and go and go. This is a function that has t instead of x as an axis. I don't know what the graph looks like, but they're asking us what happens as we head out forever and ever. So this is a question that's really just saying, what do the ends of this graph look like? And specifically, what does the right end of this graph look like? So let's treat it just like the ones we just saw, number 5. Do we have a lead term we can build a model out of? You guys say is your end model? Anybody got one? Okay, I'm gonna pick a random person I can on my notes. I want to know what you're thinking. Luis, unmute your microphone. Luis is sneaking around muted. I can't. Oh, there. Luis, can you hear me?
Yeah, I just came. I was doing something else.
You just got here?
Yeah.
Just now? So do you know
Yeah.
the problem we're talking about?
No.
Okay, we won't put you on the hook. We're talking about question 4 on the review.
Oh, okay.
AJ's here too. Hi, AJ.
Hi. Would it be 2t squared times t over t squared times t?
No, it sounds like you're trying to multiply these. These aren't factors. These are already all multiplied out. There's no parentheses.
Right.
So
Okay,
what's
well,
the lead
would
of
it
the
be
top?
plus then instead of times?
No, not even add it. Nope.
No?
Just the first term with the biggest
Oh.
degree.
That's what I was thinking. That's just not what I said.
Okay. Fair enough. Okay, so that's it for the top. What's the bottom?
T squared.
Right. So the end model is 2t squared over t squared. Y equals 2t squared over t squared, or just 2. Y equals 2. Okay, so what happens to the pollution as time goes on and on and on? And this end model tells us what the pollution is doing. What's going to help answer that is to see if you guys can tell like the unit. Everybody go back to the problem and read it again and see if you can tell what the Y value, which I've got identified right here. It's the amount of pollutants in the stream. What does that Y value represent? And what is its units? How do we measure it?
Grams.
I didn't catch that. What was that? The units? What are the units?
Would it be grams?
think so.
Gallon?
Grams per gallon or something like that. I don't have any.
Yeah.
Grams per gallon of water. So I think I can imagine they're like taking samples. They take a gallon of that water in the stream and they measure how much of that water is pollutant. They weigh the pollutants. And as time goes on and on and on, remember this is a Y value. Your end model is what Y is doing. So this is 2 grams per gallon of water. So to practice the idea of writing this in limit notation, the way we would write this is we would say the limit with the abbreviation as t, as t goes to infinity, as time goes on, the limit of the pollutants, f of t, is equal to 2 grams per gallon. And you should be able to write that out in a sentence. I think it might be helpful just to help you guys see, people have a hard time with word problems, me included. So I think it'd be helpful to look at this on the calculator. I'm gonna just do this really kind of quickly. You don't have to worry about doing it with me, but I want to just talk about what's going on. So I'm going to enter this function into Y1. Do it again. Now, if I get this typed in wrong, you better tell me. Okay, so this function tells us the amount of pollution in the stream. Now, I'm going to go to a table. And in my table, let me delete all this stuff. I'm going to put in time 0. Okay, so x is the time here, time 0. And this tells me there's 82 thirds. You can divide that if you want. There's 82 thirds of a gram per gallon. I don't know what that is, about 27 or something like that. 27 grams per gallon, we'll say. Right at the beginning. That's right when it was dumped in. So if time is in, it doesn't say if it's in days or years or anything. That's too bad. I'm going to say time is in days. Okay. So let's say a week later, and x is 7 for a week later, 7 days later. I don't like these decimals. I want to see. I'm going to try to get decimals out of this. Not sure if I know how. Okay, well, whatever 187 divided by 45 is, this isn't helpful. Let's go out though, like a whole year later. If time is in days, so 365 days later, there's a decimal for you. Okay, so a year later, after we dumped the pollution into the stream, and there's so much of it, then it's going to start to dissipate. It's going to get spread out. It's going to, I don't know, decompose or whatever. Hopefully it's going to start to dissipate. So a year later, we started with about 45 grams per gallon, and a year later we're down to about 2 grams per gallon. And if time keeps going on and we keep letting this time value get more and more, let's say it's 1,000 days later. Here's our level of pollution in that stream. We go 10,000 days later. Here's our level of pollution in that stream. So what I'm doing is I'm letting this time value go on and on. So we go forever. And we see that this starts to level off to this value of 2. That's that end model that we got. And if I make this time bigger and bigger and bigger, I still get to, I'll show you that decimal. That's the 2 that we're talking about. It's just getting closer and closer. So as time goes on in this case, the level of pollution levels off to about 2 grams per gallon that we apparently can't get rid of. So there's my little mini lecture. Do you have further questions about that one?
So is it only asking for the right side of the graph, like when x goes to positive infinity?
Yeah, good question. In this case it is, because time is going by. So time is moving forward. mathematically, we could answer the question like what happens as time goes to negative, but that wouldn't make a lot of sense in this particular problem because I think it mentioned that time was measured, time equals 0 was the beginning. So that's why I'm saying that's when it was dumped in. And negative time doesn't make sense in the context of this problem. So this stuff wouldn't make any sense back here. We would just start here and then let the time tick on forward.
Okay.
Okay, any further questions about that one? You guys, a lot of you have sent me questions like just before this meeting started, so I didn't get a chance to read them. I don't want to miss any of them. So I'm going to actually open it up to you. And I'm going to call on each of you one at a time and ask you to ask me a question, and we will go over it. If you have your question answered in that process, then find another one. So Shannon, we're going to start with yours. You did text me one, but I don't understand.
There was a delta math problem I had that like I was really confused on.
X minus 15 divided by negative x squared plus 5x. That one?
Yeah, that.
Okay. That's one you want to factor. So 3x, did it just ask you to divide that? Or to do something with it?
It said to like find the steps and like the asymptotes and rules and stuff.
And you're really breaking up. Try that again.
It
Try
said
that
to
again.
find the folds and asymptotes and intercepts of it.
Oh, okay. So you're doing basically all the analysis of it. I would start it by factoring it. Take out on the top a 3. And then out on the bottom, you should take that negative out. Was it negative x squared? Yeah, it was. That's what your question says. On the bottom, I'd take out a negative x. And I'm thinking that this would be x minus 5, right? You've got a common factor there. What does that mean when there's a common factor? Everybody should know this. You're scaring me, you guys. What does it mean?
There's
a hole.
Oh, yay. Okay, good. There's a hole. Where's the hole?
Positive 5
Good.
x.
Okay, so there's a hole at positive 5. And the y value, I keep getting the same question. How do we get the y value? Plug the number for x into the simplified version after you've canceled it. Plug that number for x in, and then what you get out is your y. So this one would be 3 divided by negative 5x. So Shannon, what was your specific question on this problem?
One second, I have to like find it in my notebook. But
Okay.
the vertical and horizontal asymptotes, I got those ones wrong.
Okay. Okay, so every time you do a problem like this, once you find the hole, write that down, get its y value, and then everything should be from the simplified version. Don't ever go back. So this is what we're going to use. For vertical asymptotes, does the denominator ever equal 0? You want to set the denominator equal to 0, and since it has an x, there should be an answer for it. I'm getting x is 0. Questions about that?
No, I got 0 for both of them though.
Oh, you got 0 also for the horizontal asymptote. Yeah, I believe it is. That's bottom heavy. Horizontal asymptote's bottom heavy here. Okay, this meeting's gonna end in 10 minutes, so I'm gonna just start a new one. You guys might have to rejoin. I'm gonna finish this example, then I'm gonna start a new meeting, okay?
Okay.
Okay, so it's bottom heavy, so there is a horizontal asymptote, and you're right, it is y equals 0. Anytime a function's bottom heavy. So x is 0 and y equals 0. That's two different lines though. One of them's vertical and one's horizontal. Is that where your question was?
Yes.
Okay, so I'm going to show this on a graph. So here's my x and y axis. The vertical is where x is 0. When x is 0, that's actually the y axis. You guys, I don't know that. Well, that's right here. And the y equals 0 line is actually the x axis. That's here. Horizontal. And then you have a hole. That's actually some information. If you had to graph this, I don't know if you had to, but if you had to graph it, that hole would be helpful. It's at 5. Oh, it's down here, -3/5. So there's a hole in the graph. There's a target as well, though. So this graph on the ends is approaching the 0, and the hole tells me that it's approaching from below. It's coming like something like that. That'd be my next target. Working this way towards the asymptote, I'm going to go down to -infinity. Because the graph doesn't allow me to go up, that would require crossing the axis, and I can't. And then I'm going to jump, because I was going down on this side, I'm going to jump to up on this side, and I'm going to come and level off towards the 0. So that's probably what the answer looked like. That was quick. Do you need any further explanation on that graph?
No, I think I just switched the negatives on the whole.
Oh, okay. On your graph, okay. All right. Luis, question. Oh, I lost Luis. Okay, let's go to Sari.
Okay, on question 6 on the review, it says to describe any asymptotic behavior in terms of a limit, and I'm not sure what that means.
Asymptotic is how you say that. That's a fun word.
Oh, okay.
Okay, that means what we were talking about with question 5A. Were you here for that? I know I wasn't recording it, but I think you were here for that.
Yeah.
Okay, so that means that if there is an asymptote, then I want you to describe that behavior using a limit. So 5B, actually. 5B had an asymptote. This function is balanced, and so that means that the y equals 2/3 equation is an asymptote, a horizontal asymptote. And the way to describe it is using this limit notation. As we go farther and farther to the right and x approaches infinity, g of x gets closer and closer to 2/3. That's a verbal description of an asymptote.
Okay.
And then same on the left end. Now, if you look at the solutions, if you look at the solutions, you will notice probably on that question 6 that I do the same description with the vertical asymptotes. But I think there's a note that says that that is something that we are skipping for this unit. Because with trimesters, the truth is with trimesters, we have to cut some stuff. And that kind of got cut. So don't worry about it for the test. I am going to come back to this question we just did from Shannon's question. And I'm going to write down those limits. I'm going to write down the ones you need to be able to write, and then I'm going to just as a side note write the ones that you don't have to know for the test, just to complete it, okay?
Okay.
All right, so you guys will need to know how to write this end. The end behavior I want you to write as a limit. So which end are we doing? Where's x going on this end?
Infinity.
Name of the function is right here, is f of x. Put the name of the function and then write down what it equals. The limit as x goes farther out is the y value that this graph approaches. What is y going closer to?
0.
So you'll notice there's a definite connection between your answer for the for the horizontal asymptote and what your limit statement should say. These always match right here. They always match. Same over here. I want you to know what the left end is doing. Okay, so how do we write the limit for this end? What's x going to?
Negative infinity.
Where's y going as x goes farther to the left?
0.
So that's what you have to know how to do for the test. What I wish you could know how to do if we had more time would be to write down what this limit is right here. This is another asymptote, so I can use a limit to describe it. And so for this one, I would say the limit as x is approaching, now x isn't approaching infinity in this one. X is getting closer and closer to a 0. We're getting closer to where this asymptote is, which is where x is 0, this 0 right here. So I say x is approaching 0, and I'm coming from the right side. So I would put a little plus sign there because I'm coming from the right side of 0, just a little bigger than 0. And then I would say that f of x is approaching negative infinity because the y values are going down. And I'm going to stop right there because, like I said, you guys don't have to be able to do that for the test. But just make sure you know how to talk about the far ends of the graph. Does that help?
Yes, thank you.
Okay. Okay, I'm down to 3 minutes left on this meeting, so I'm going to end the meeting and I'm going to start a new one. I think you guys can join it with the exact same code I sent you before. So let's go ahead and do that, and I'll see you in a sec.
Okay.